Okay, so the last journal question, and this one is using quadratic equation. And we're going to try and visualize a quadratic equation just to remind you that when we have x to the power of 1, which is just really x, that is what we call a linear function. And we had a straight line graph for this. For the x to the power of 2, we call this a quadratic function, and this gives us a parabolic shape. So it's going to be a smiley face if it's a positive x squared, and then we have a kind of frown face if it's minus x squared. We have a function here where it's t squared, so 4t squared, so this is going to be a positive smiley face type of function. So just to give you a little bit of context, the power on the x lets us know, or on the t in our situation, lets us know that it's a quadratic equation. Okay, so let's have a go at solving this one. My rubber isn't working there, but we can ignore that for now. Okay, so what we have is we have this formula here. H is equal to 4t squared minus 62t plus 300. And we want to find out what the bungee jumper's height is after 10 seconds. So we're looking for the value of H when we input a value of 10 for t. So we're going to have a go at doing that. So H is equal to, and sometimes when you type it, it does that. You have to go back and undo that. So we have 4 star, and the 10 is 10 seconds to the power of 2 because it's squared, minus 62, and then we're going to say star brackets 10, and then it's going to be plus 300. And remember, OneNote should do the work for you. So if we press equal to in space, it does it for us here. And so the answer to this one is the height is equal to 80 meters. So after 10 seconds, he's at a height, after falling to a height, or she, of 80 meters. The next thing we're going to do is we're going to try to visualize this graph, and I'm going to encourage you to use Desmos for this, and I'm happy for you to take a snipping of your Desmos graph for this. What I do want to highlight is that the time is between 0 and 12 seconds. So it's a time greater than 0 and less than so greater or equal to 0, so it could be 0, or less than or equal to 12. So we're going to just make sure on our x-axis, which is the time, that that's the scale that we are including. And so we're going to go and find Desmos here. So we're going to jump in and we're going to find our Desmos calculator here. And we're just going to, now if you can't find it, you can just go into Google and say Desmos calculator and it should come up. Now there's a calculator, a scientific calculator, or there's a graphing one, and I'm interested in the graphing one. So we're going to type in our function h is equal to, and we have 4t to be squared. So you use the little caret symbol like we have been using above the 6 to do that. Then we have minus 62t and then plus 300. So let's have a look to see how this looks on our graph here. So something didn't quite work there. So we're just gonna, and it's good when it doesn't work. So we can just see what's happening here. So we have h is equal to 4 um, t to the power of 2. And then we have minus 62t and plus 300. Okay, and it seems to have disappeared off here. And I think maybe what's happened is, there it is here. Okay. Now the next thing we're going to do is we're going to make sure that the scale is okay on this. So remember I told you to set the scale on the x-axis so that it is between 0. So I'm going to put in 0 here. So 0 and 12. And this kind of makes it a little bit more easy for us to read here. So 0 and 12. And the other thing we want to do is we want to put our labels on our axis. So here, again, back into this little tool here, we're going to put on our x-axis, we're going to call this time, and this as a unit of seconds. And on the y-axis, we're going to put in height. And this is in meters. So you can see where this is intersecting here with the y-axis is 0 and 300, and you can see it's making that parabolic shape here that we talked about. So what I'm going to do next is I'm going to take a little snipping of this so that we can bring it into our journal. So we have our equation, we have our function here, we have our axis labeled, so you can see the time and the height are here. And if you want to make it a little bit bigger or anything like that, you can. But I'm just going to try and get the time in here as well on the screen. So we're going to go for a snipping tool. I'm going to go to new, and I'm going to just grab a picture here of this with the label. I'm going to paste that in, and we can put a label on our graph. So the label is going to be height in meters versus time in seconds. So we've solved for the bungee jumper's height after 10 seconds, and then we have created a graph of this function here, of this quadratic function, and you can see it's that parabolic shape. I'm happy for you to do it in Desmos, so you just have to get a little bit used to how to use that and then take a snipping of the screen.